6.5, dividing radical expressions. So again, this is the root. This is the radical. Now, just like multiplying, we can divide when we have the same index. We can divide when we have the same index like this. We can just move the radical over the whole fraction. Or if we have a whole fraction, we can move the radical over the top and bottom. So for this first one, I can rewrite this. So whenever you have the radical with the same index on top and bottom, you can rewrite this as the fraction on the inside, 18x to the fifth over 2x to the third. Now you can simplify that fraction. Notice how I'm not simplifying the radical, I'm simplifying this fraction. 18 divided by 2 is 9, so I can have a 9 on top because 18 divided by 2 is simplifying that fraction. And remember, when we are dividing with the same base, we are subtracting. So I can do 5 take away 3, that would give me x squared. Now I can move that radical over the top and over the bottom again. So this right here, the square root of 9 is 3. The square root of x squared, there is one group of 2 in 2, so there's 1x. Oh, the square root of 1 is 1. You don't need this one on bottom, but you sure can have it if you wish to. I want you to try to simplify this one by yourself. So here again, I can simplify moving the radical over just the fraction. If I do 162 divided by 3, I can do that. That's 54. So now I can rewrite this as the cubic root of 54, y to the third, over the cubic root of 1. So here, I'm going to have to simplify my cubic root of 54, or see if I can simplify it. So this would be the same thing as 6 times 9, 3 times 3. This is 3 times 2. So again, I'm working on this part right here. There's one group of 3 here, so I can take 1 3 out. When I'm looking at my y's, there's one group of 3 in y, so I can take out 1 y. This 2 is left underneath the root. So now I have my cubic root of 2. The cubic root of 1 is 1. Again, you don't need to have that 1, but you sure can if you wish to. And I want you to pause the video and try C all the way to end. Get all the way to the end by yourself. Now, I did this one a little bit differently. Because I know that I can rewrite it like these two appear, I didn't rewrite it, but I just simplified this fraction because the indexes were the same. So 50 divided by 2 is 25. 6 subtract 4, that's where I get the x squared. And the square root of 25 is 5, and the square root of x squared is x. You could have this over 1, but you do not need to. Now we're going to get into rationalizing denominators. I'm not going to do all of these. I'm going to do the first two. So what rationalizing denominator is we do not want a radical on the bottom of the fraction. We can have it on the top, that's fine with us, but we do not want on the bottom. So when we rationalize this, we need to try to force a pair. Because remember, in this case, because my index here is 2, I need a group of 2 in order to simplify that radical. Right now I only have 1. I have one part of it. So I need to multiply it by the square root of 3. This is kind of like what we have done when we had imaginary numbers. So now I'm just multiplying by 1. So now I multiply across. So this becomes 2 square root of 3 over the square root of 3 times square root of 3 is 9. At this point, this should become a perfect square. And the perfect square of 9 is 3. I can't simplify that anymore because this is underneath the root and this one's not. So this right here is my final answer. The same thing would happen here. The difference though is I'm going to simplify this fraction first. Both of these are underneath the root 2. So I can actually rewrite this. They're both divisible by 3 as divide by 3, divide by 3. Now, this is actually just equal to 1. The square root of 1 is 1. When I rationalize this, I have to match the bottom. I have to match my denominator. So I have to multiply by the square root of 2x over the square root of 2x. I'm not changing my problem here at all because I'm multiplying by 1. So I multiply across, I get the square root of 2x. And on bottom, when I multiply across, I get the square root of 4x squared. And again, this should come up to be a perfect square. So the square root of 2x over 2x. Do not simplify. This one is in the barrier. Radical is like a barrier. It's in a box. It's in jail. Can't do anything with it. That's my final answer. So I'm going to do the first two, and then I want you to try to do the second two. So the first thing I look is writing this, or seeing if I can simplify anything here. I can't simplify anything. But now I'm looking at this. Here we have a cubic root. That means we need groups of 3. I'm going to rewrite, actually this one I do. I'm going to multiply this by, it has to be the cubic root on top and the cubic root on bottom. Okay, cubic root on top and bottom. I have 112 here. So that means I need 2 more 12. So I'm going to do 12 squared for both of them because I need a group of 3. I have 2 y's. That means I need 1 more y. I only need 1 more y. Now I have 1 z. That means I need 2 more z's. 2 more z's. So I'm trying to complete the group of 3. Now you multiply on top and you multiply on bottom. So I see what can I simplify, or what can I multiply here? 12 squared times 5. So I still have my cubic root. This gives me 720. X squared, because there's nothing else there. And then I have a y and I have a z squared. That's all on top. On bottom, if I do 12 times 12 squared, I don't know what 12 times 12 squared is. 12 times 12 squared is equal to 1,728. And then y squared times y, that's a total of 3 y's. And z times z squared is a total of 3 z's. This should become a perfect square, or I mean a cubic root. So I'm going to do raise the 1/3 power, because remember that's the same thing as a cubic root. So this is equal to 12. So on top, I'm going to have the cubic root of 720 x squared y z squared. On bottom I'll have 12. The cubic root of y cubed is y. The cubic root of z cubed is z. And that right there, you could see if you can simplify this further, which I think you might be able to do, but we're going to leave our answer just like this for now. So same type of thing here. I want you to try to pause the video and figure out what should you multiply by. Pause the video, figure out what should you multiply by. I have 1 5. I need groups of 3. I have 1 5. That means I need 2 more 5s. I have 2 y's. I need 1 more y. So I should multiply by the cubic root of 5 squared times y. So right now I want you to multiply that across. Pause the video, multiply that across, and see if you get the same thing as I do. You should get a cubic root of 175 xy over the cubic root of 125 y cubed. So this stays as is. 175 xy. Cubic root of 125 is 5. The cubic root of y cubed is y. That's my final answer. This one, what I can do first is I can simplify that fraction because they both have a radical of 3. So I can simplify this fraction. 15 divided by 5, that's going to be equal to 3. X squared divided by x is x. So I'm just left with a 1 on bottom. So that's my final answer. Once you get rid of this, because the cubic root of 1 is 1, I don't have to do anything further. That's my final answer. I don't have to do any of that hard stuff. But now I want you to try to do D by yourself. Do D by yourself. I can simplify the fraction just like above. The difference, though, of these, I can't simplify this any further. I can simplify this further. I can't simplify the 3, but I could rewrite this so it looks like the square root of x to the 4th times x. So now remember, if there's no number, I'm looking for groups of 2. So how many groups of 2 are in 4? There are 2 groups of 2. So I can take out 2 x's here, leaving me with 1 x in the middle, or in the radical. And that's my final answer. And there you go. Bing, bada, boom. Have a great grand Monday.